Good morning, everyone, and thank you for joining us today on our webinar. I'm Elan de la Forest, and I'm the Executive Director of the Passivhaus Alberta Nonprofit Foundation. My co-host and colleague is the Vice President of our board, Frank Crawford.
Hello, everyone. Thank you all for joining. Thank you for your interest in Passivhaus and your interest in energy efficient building.
All right, without further delay, let's begin. So we're here today on the webinar to talk about how to achieve 90% energy savings in your new home or renovation using the Passivhaus approach. I also wanted to note that this presentation is designed and presented from an accredited engineering, Passivhaus, and environmental perspective. So the vision for our foundation is that Passivhaus is the standard for the built environment across Alberta, accessible and affordable for all. Now, why would we want to have a vision of different buildings in the province? Well, it's because the bulk of buildings constructed today are built to methods that are essentially from the 1950s and the 1960s. And things have changed, and frankly, this was a time frame before many of us were even born. So what that looks like in real perspective, these two homes are here in Calgary, and you can see clearly they're built in different eras. The 1950s house has different materials on the outside. Visually, it looks different. Smaller footprint even, and compared to the newer building. All of that said, they are built using the same construction methods. They both have furnaces for heating. They both have very similar wall assemblies and such. So even though almost between 50 and 70 years separates these two homes, they really are very much the same. And frankly, we're stuck in a bit of a rut. So because we're building to the same standards, we're starting to see the same problems over and over and over again in our buildings. I want you to just cast your mind back to January or February of this year. Deep winter, very cold here in Alberta. Did you happen to have in your home one room that was colder than the rest in your house and nobody really wanted to be in there because it just wasn't comfortable? Were you able in February to sit with a cup of tea in front of the window and watch the snow fall? Or was the window drafty? Perhaps there was condensation on the glass or even frost building up. And how about your heating bills in this time? Your furnaces running, which are generating these heating bills, recirculating very dry, perhaps stale air full of dust. And were you noticing the dust settling out onto your furniture and even on the floor where your babies are crawling and your pets are walking through it? So let's think about the upcoming summer even. End of July, peak of summer, sunny Alberta, what we're known for. Are you fully anticipating that the second floor of your home or your apartment building is going to be much hotter than the rest of the place, and you're planning on, frankly, sleeping in the basement just to get some relief? How about, do you anticipate paying for air conditioning or some other method to cool your space? And if you think about 9 o'clock in the evening on those hot summer days, is it, frankly, colder outside or cooler outside than it is inside your house? So you're walking around, opening doors, opening windows, trying to get some heat moving to cool your space off. All of these things are a result because buildings built to code fail in terms of comfort, in terms of indoor health quality, and in terms of superior energy efficiency. Now, to be sure, built to code means you have a safe building. And you can be assured that when you're in your home, your workplace, or even the buildings where your communities gather, that it's not going to collapse around you, that the electrical, the plumbing, the fire ratings and such are certainly at a standard that is safe. It is a safe building, but frankly, it is not designed for comfort. It doesn't think about exceptional indoor air quality nor superior energy efficiency. So let's think about some of the other certifications of buildings that you may have already heard about to date. Now, we've talked about code. R2000 was an energy efficiency program that started in the 1980s, and LEED started to enter mainstream popularity and began about 20 years ago. and we've certainly heard net zero in the past few years. Well, Passivhaus really sets the standard for energy efficiency and comfort. There is a better way to build. Passivhaus sets that standard. And Passivhaus, we can think of it as we are redefining safe and healthy buildings. The great news is there is a much better way to build.
Not that we expected this, but this happened, is that it has had a pretty big impact on the quality of our lives here. Having a lot of access to natural light definitely has an impact on mood states and how we're doing mentally. Having the sunshine in and having bright light even on a rainy day like today is quite profound.
The other thing we really enjoy is just the quietness of the house. You can't hear a lot of the exterior stuff that you normally hear in a normal house. And then the last thing is the temperature fluctuations aren't as big, so it's much more comfortable and you're more connected to your environment.
In addition, I think I'll also add that just the noise from the interior running of a house, for example, the one thing we always notice when we come home from visiting others is the furnace or the air conditioner going on in the middle of the night in particular. Like even our kids feel like they're waking up at an airport in the middle of the night sometimes. So having that type of quiet and that reduction in noise pollution in the house is really profound.
Over the years that we've lived here, we've noticed that the air quality is significantly better than our older conventional house that we used to live in. So as an example, during the fires that were in Alberta last year, we closed all of our windows and everything else, and we're running the HRV at a relatively high rate to filter out all the ash and everything else that was in the air, and our air quality was significantly better inside than outside. The other thing is that you can turn the HRV down onto low in the summer, and it's really nice because you can open up a lot of the windows and get a lot of the fresh air inside of the house, and close them up during the nighttime, and the house reacts really well, and it's good temperature in the morning.
The house is modeled in terms of heat and how it insulates. That if it's a minus 30 day, it's minus 30 outside, it's 18 right at the window, and it's about 20 degrees in my space. And that's nice, that's great to know. However, from a functional perspective, when I live in it, if I was to close my eyes and I go from being at the wall to being at the window, back to the wall, I can't tell the difference. If I'm sitting at my dining room table, which is right in front of the window, I will never feel a draft. And that's the type of comfort that I really enjoy in this house. Particularly because oftentimes we've been at other people's homes in a kitchen, same design, and you're uncomfortable, you need a blanket, you need a sweater because there's a constant draft traveling across your back. And so that's another one of those pieces that it seems so small, and yet it has a really significant impact on how you enjoy the space you live in.
Now, some of the seeds for Passivhaus were born in Canada, actually, and German scientists took these seeds, expanded on them, added to them, tested, retested, and came up with the 5 main principles of whole house design. And we apologize for this slight technical glitch. Passivhaus is not a single technology, but 5 key principles that work together to give you a healthier, more comfortable house. Every single Passivhaus building planned and constructed in the world follows or utilizes these 5 main principles. And I'm going to turn you over to Frank Crawford for some more detail on this.
Thank you, Elaine. So the first principle, which has been up on the screen a few times now, is insulation. So we should understand this. In the winter in Canada, or especially Alberta, it gets cold. So when we go outside, we put on a big winter jacket, we put a toque on our head, we put a scarf around our neck, we put on gloves, we put on snow pants, and we put on winter boots. Our buildings should do this as well. Our buildings in Alberta should put on a big winter jacket. We need lots of insulation in the roof. We need lots of insulation above grade. We're fairly good at that. Once you get to below grade or in your basement, put a little bit of insulation, but not much. And right now, code doesn't require us to put any insulation below grade, underneath the foundations, or our basement floor is always very cold. So we should be putting on a much warmer winter jacket than we are right now. And what by doing this is right now we're kind of living and working in big glass coffee pots, which means that in order to keep them at a somewhat comfortable temperature, we have to be adding active heat, active energy, or active cooling in the summer to keep them at that comfortable temperature. Whereas if we have a passive house building, that passive thick layer of insulation all the way around the thermos makes sure that more of that heat that we pay for to heat the building and cool the building stays in the building longer. Because what insulation does is it slows the transfer of heat. In the winter, it slows the transfer of heat from the inside the building outside to the cold. And in the summer, it also works by slowing the transfer of the warmth from outside into the building, so your building stays cooler in the summer and hotter in the winter longer. The next principle is airtightness. So with airtightness, really what it means is not you put on your big jacket, you want to zip up the zipper, which stops the wind from coming in and pulling away and washing away all of that warm air that you just paid to heat. So in the jacket, what you do is you do up the zipper. With a house, what you do is you take some tapes, high quality tapes, some membranes, some caulking, and various other materials to basically do up the zippers and cover all the cracks in your walls, so that you end up with an airtight house that then keeps the air, heated air or cooled air, inside the house longer. And then to actually test this, because you don't just want to plan it, you want to test it, you do what's called a blower door test. And a blower door test is where, as you see in the picture, they put a big fan in your door and they pressurize or depressurize the house, and then they can calculate how much air is leaking out through the remaining cracks in your house. And if you did this to a code minimum building right now, you'd be getting between 2.5 to 3.2 air changes per hour. That means 2.5 volumes of that air inside the house leak in or leak out every hour. So that's code building. But passive house gets you down to 0.6, or most buildings are actually being lower than this, 0.6 or less air changes per hour. So significantly less air changes. Your zipper is done up. You're keeping the warmed or cooled air inside your house longer. The next principle is called thermal bridge free. And what is a thermal bridge? A thermal bridge is anywhere you have a lower reduced area of insulation compared to a normal wall. So there's some thermal bridges that you want to minimize. There's other thermal bridges that you want to eliminate. So an example of, going back to the jacket analogy, the thermal bridge would be that zipper. Even though the zipper is done up, it still has less insulation than the rest of the jacket. So you would put an insulated flap and button it up over top of the zipper. Another one would be the gap between your jacket and your toque, so you wear a scarf around that. In the house, the thermal bridges that you can eliminate are putting insulation underneath your slab, because that slab or the floor of your basement is a big thermal bridge being not insulated. So you put insulation and it then goes away. The other ones that you can't really get rid of, and this photo here shows that, the thermal bridging through the wood studs in your wall. So thermal bridge, less insulation, so more energy goes out. So you can see that energy being transferred out through the wood, showing up as melted areas on an otherwise frosty stucco exterior. Some other thermal bridges that you want to minimize would be a beam running from inside the building to outside the building and just transfers heat or cold in or out all the time. And the final thermal bridge that you just want to minimize would be your corners, as a corner is always loses more energy than a flat wall. The next principle are windows and doors, and there's a few parts to this one. So the first one is you want to use high quality doors, frames, and triple pane glazing that is Passivhaus certified and rated. The reason for this is that a window is a thermal bridge compared to the wall beside it. And if you use the Passivhaus certified, your walls or your windows can be in the R6 to R8 effective R value, which is a lot better than your uncertified double pane glass, which is kind of your R2, maybe R3. So you want to use high quality ones. And then the other part of the higher quality windows, it gives you a much higher air tightness, often 10 times more airtight than an uncertified frame. Again, this helps the air tightness of your whole building and keeps the energy in instead of letting it out. The next part is the actual location and then the orientation of the windows. So in the winter in Alberta, it's cold, but it is still sunny. So we want to let as much of that sun into the house as we can. So we place more windows on the south side of your building, if possible, if it sees the sun. And then that low angle winter sun comes through the window and heats up the space inside. And by using the high quality windows, that window is a net heat gain over the whole heating season. But the problem is, if you then go to the summer, and this is why lots of buildings overheat, the sun is higher, but it's still hotter, and the air outside is hotter. So you now need to shade your windows. Back to the jacket. Well, not the jacket, but we all know that if it's summer, if we're standing under a shady tree, it is a lot cooler than if we're standing in the sun. So we want our buildings to essentially be sitting in the shade. So as this graphic shows, you put an overhang outside your south windows, and that blocks the summer sun from going into your house and overheating your house. So those are your south windows. The north windows, they obviously never see the sun in the winter or in the summer, so you don't want to have as many of them. You still want enough for good daylighting and good light penetration into the house, but you don't want a ton of north windows. And then east and west windows, because the sun rises and sets, are very hard to shade with overhangs. You need to use a different shading technique on your east and west windows, so you want to minimize those to reduce the overheating in the summer. And then the final thing with windows is what you can do, what's called cross ventilation. So you can have windows on different sides of your house or different levels on your house, like a basement or a main floor and an upper level, and you open them in the summer, and then just through convection flow, the cool air will come in through the lower window and the hot air will go out the upper window. So this way you can get free cooling, because in Alberta, it almost always cools off in the evenings. Then the final principle is ventilation. So now that you've made a super insulated, airtight, thermal bridge free house, you can't breathe air through the cracks in the walls, which is really what you're doing now, especially in the summer when your furnace fan is off. So you can't breathe through the cracks in the walls, so you need mechanical ventilation. And it needs to be continuous, filtered, balanced, commissioned, and you do this by putting it through what's called a heat recovery ventilator, or an HRV. And what an HRV does, as you can see in this graphic, is it takes the warm, moist, but stale air that's exhausted from the house, and it crosses that through a heat exchanger with the cold, but fresh and filtered supply air, and then the heat transfers from one to the other, so it kind of preheats your fresh air. That's what a heat recovery ventilator does. An ERV, or an energy recovery ventilator, also transfers the moisture. Think of like a Gore-Tex jacket. So you get some humidity being recycled back into your house, so your house isn't as dry in the summer. So that's what the heat recovery ventilator does. And there are lower quality ones. They're about maybe 40 to 60% efficient. With a Passivhaus certified HRV, you're looking at 80 plus energy efficiency, so that again, you're keeping more of that heated air. You're not just exhausting it to the outside, you're keeping that heat inside the house. So going back, you want it continuous. And what continuous means is that it's running all the time. It's running 24/7, every day of the year. It's running at a low volume, but it's always providing you sufficient fresh air. And then, as you saw in that video from some other Passivhaus owners, you want it to be filtered. And that filters that you put in your HRV filter out all the pollen, all the allergens, the other pollution, and if it's a high enough quality filter, will filter out all of the smoke. So you have a nice high quality filter on the supply air, and then you also filter the stale air, because you want to keep all of those, the dander, the pet hair, and any other pollution or contaminants that come from inside the house from clogging up your heat exchanger. So that's continuous, that's a filtered. Next, you want it to be balanced. So by balanced, that means the same amount of air that's coming into the house is also going out of the house. You want that because if it's not balanced, if say you're exhausting more air than you're bringing in, that difference has to be made up somewhere, and it'll be made up through the cracks in your walls. So you're pulling air again through the cracks in your walls. And if the cracks happen to be in your basement, you're pulling the air through the cracks in your basement, and that might actually pull more radon into your house, which you don't want. So you want it generally balanced. You could be a little bit positive, be pushing the air out of the cracks, but generally you want it to be balanced. The last thing you want is commissioned. And what commissioning does is once the system is up and operational and everything should be working as it is, you have someone that's a trained technician come in to check that actually all of the airflows out of each of the supply and exhaust diffusers are what the design intended. Again, so you're actually testing and confirming that what you designed and wanted is what you're actually getting. And then the final thing with ventilation is you supply all the air into your bedrooms and living rooms, so you're always getting the fresh, filtered, continuous air into your living areas, and then you exhaust the stale air from your bathrooms and your kitchens, so that all of the areas that generally create more of the smells and more of the pollutants, that air is being sucked away all the time and not blown around your house, which is what often happens if you have a furnace supply vent in your bathroom. And by doing this supply and exhaust and continuous, you are always moving the air around your house, and that's one of the things that helps it maintain a nice constant temperature everywhere. You don't have stale areas, and also by having a high quality HRV, it's not very noisy, and that's how you keep the sound in your house down. So finally, these 5 principles work together. You can't just pick the ones you want, you have to do them all. And you can't kind of shoehorn Passivhaus into a design at the end. You have to start early before you have the plans, because the vast majority, up to 90% of your decisions on energy efficiency design are decided even before you have the plans, at the very initial stage. So items like the orientation. Is the long side of your house facing south? Does your house even see the sun, or are you shaded by adjacent buildings or trees? Is it a simple shape, or does it have lots of corners, bump outs, zigzags that will make you lose more energy? And also, is it smaller, right size, as opposed to oversized, because you still have to heat the space. Also on this slide, you can kind of see some of the differences in code R values, or insulation values, between a code minimum and a Passivhaus. And again, back to the air tightness. So by doing all 5 of these principles early on, the results. Well, one of the results is you don't need a fancy, complicated, hard to maintain, hard to understand, hard to use mechanical system, which is kind of, as you see in that graphic, where we were in the 20th century right now with our, we didn't make the building envelope any better, didn't insulate anymore, but we still want comfort, so you have to add all these fancy, complicated machines to keep it comfortable. Whereas now, in the 21st century, if you do Passivhaus, we have more insulation, and we just need a few smaller mechanical equipment to keep us warm and healthy. The other result, obviously, that we've said before, is lower energy bills. And this lower energy bills is from the lower energy consumption. Over 75%, up to 90% energy reduction over a code minimum house obviously gets you less energy bills. And again, as Alon had said before, you get all of the comfort benefits as well. So the next question is, it's cold here. Can we actually do it? And the emphatic answer is yes. There is a small but growing number of Passivhaus buildings built all over the province of Alberta that are providing comfort and energy efficiency and reduced energy bills to their occupants. And the Montgomery Passivhaus, which me and my family have been living in for the past 3 years, we definitely agree with all of these benefits. They do exist. It's not just fairy tales. You get lower bills, you get comfort, and it's a lovely place to go and spend all your time. Now back to Lana.
Thank you, Frank. How we define safe and healthy buildings is fundamentally changing. And Passivhaus, it meets that change. It's the future of better buildings because it designs for comfort. The comfort criteria is built right in. A healthy indoor environment, superior energy efficiency, and of course, safety. Invest today in buildings that save for tomorrow, because Passivhaus, overall, these buildings cost less to operate and they have lower utility bills. They do provide exceptionally healthy indoor air, and the environmental savings are significant as well. There are less greenhouse gas emissions from Passivhaus buildings, less energy is used for heat or cooling purposes, And fundamentally, you get a more durable building that lasts longer than typical buildings today. So let's get to work. Stay tuned. We are excited to announce that we have some upcoming one-day courses that are going to be offered throughout Alberta starting in September. Please feel free to check out our website, and we can keep you posted if you sign up for a newsletter, or if you would like to follow us on social media, or even look at the membership options for our organization. Now, to summarize, we cannot leave today without thanking our major sponsor, Energy Efficiency Alberta. Sincerely, their encouragement and support has been so valuable as we have moved forward along this journey. Other sponsors that have participated, whether it be providing resources and pictures for the webinar, or even helping the Passivhaus Nonprofit Foundation get going, are mentioned here, and we sincerely thank you for your support as well. All right, so it looks like we are ready to look at your questions. Pardon us while we find the chat space. And it looks like, Frank, if you want to take this first one.
Yeah, so we have a question about what is the optimal overhang length in Calgary, Edmonton area. So this would be, going back to the windows, the overhang that extends out from your window to stop the shading getting into your window. And I guess it depends on how high the window is. If you have full light windows, it's going to be a different overhang than if you just have kind of 3 or 4 foot windows. But generally it's kind of the 2 or 3 foot length. But there are a few free, there is the energy model that Passivhaus does. It will model it and tell you, so you can play around with that dimension in your kind of your design phase to extend or shrink the overhangs to adjust your overheating of your house. There's also some other software where you can actually visually see throughout the year how much the overhang shades your window. And what we can do is we will post the links to those later on, so you can come back and see. But it's your 2 to 3 feet is generally the number that needs to be used in the Calgary and Edmonton area. So we have another question, and this is the question that always comes up. Is it a lot more expensive to build a Passivhaus standard? And the answer is it depends. When you're building in nicer climates, like in Vancouver, the upcharge is only in the 3 to 4%. Once you come kind of across the mountains into Alberta, which is a lot more colder, so we need a lot more insulation and a few other additional items, it does go up. It's probably in Calgary right now, it's kind of in your 5 to maybe 15%. And the reason is that large of a variance is, again, it comes back to how simple of a design is it? Are you just kind of a rectangular box with not many corners and not many details, or are you a very, very more convoluted design? The more complex the design becomes, the higher the cost is. But if you keep it to a simple design, you can bring down those costs into a much more manageable number. And whenever I talk about costs, my answer or my question back to the owners are, what is the cost payback of your granite countertops? What is the payback of your wood flooring? If you're going to put a cost payback to the energy efficiency upgrades, you need to put some type of payback analysis to your finishes as well. Just looking at some other questions. If you're considering a new build, can you ask your builder to build to the Passivhaus standard? And fortunately, that answer is becoming closer to yes. Again, you can't just ask any builder, but there are, especially in all the bigger jurisdictions in Alberta, there are 1 or 2 builders that know what Passivhaus are and know how to build to that standard. And there's definitely the consultants that can work either remotely or in each of the areas to help you design and help your architect and your builder get to that standard. Yes, it can be done. It's just, we're in the beginning phase, So it's not, you can't ask everyone at this point.
Another question that's come in, where can I find out more about Passivhaus in general? And there are a number of very, very good websites available for you to access. Passivhaus Canada is one of them to look at examples of Passivhaus buildings across Canada and situations such as that. And also Passivhaus International, kind of the organization set up that's started it all, if you will. They have some exceptional resources available on everything from the history of Passivhaus to conferences that are coming up worldwide. People gather to discuss and communicate about Passivhaus. So.
Yeah, and Passivhaus Alberta will be posting more information and more links to other great sites as we grow.
Okay, well, we're not, I guess we can, it looks like we might have a question coming in. What are the steps in becoming a certified Passivhaus designer?
Okay, so the steps becoming certified is obviously do a little bit of education yourself, read some stuff online, but then you take a multi-day course. It's generally either a 5 or an 8-day course. Often it is broken up from one of the accredited Passivhaus certification companies. Passivhaus Canada is one, Stitch Consulting is another, Peel Passivhaus is starting to have some online items. So again, we will put some links to some of the locations that you can take this training from on our website that you can look at. And hopefully in the not so near future, Passivhaus Alberta will be actually offering these courses in addition to the 1-day course. But I guess your first step would probably to take the 1-day course in a location near to you, do some of the online stuff, and then progress on to the multi-day course. And then after you take the course, there's an exam. And the exam is fairly challenging, as I guess it should be, to make sure you understand all the principles and how they are applied. And that exam, again, is offered by the same certifiers that offer the course. And then once you pass that exam, then you are a certified Passivhaus designer or consultant. And there is also training for tradesmen, so that you can become a Passivhaus certified tradesperson, so that you're the one that's actually sticking the tapes up and installing all of the portions.
Oh, you're welcome. Thank you for your question. Well, we'll give everybody a moment to see if there's another question coming in, but on behalf of Frank and I, if I may say, we sincerely thank you for joining in with us today to learn about Passivhaus and the better buildings it creates. We encourage you to, again, check out our website for updates on events and such that are coming out. And we thank you for joining us. Have a great day, everybody.